Hello everyone, welcome to Aakruthi, Art of Mathematics, Simple Mathematics classes. I am Sudhir MK. In this class, I am discussing multiple choice questions from real numbers. Please subscribe this channel, also like and share this video. First question, the prime factorization of 3825 is. So here we have to write prime factorization of 3825. So first we divide 3825 by prime number. So it is divided by 5. So we get 765. So again we divide it by 5. So we get 153. So again we divide it by 3. So we get 51. Again we divide it by 3. So we get 17. So therefore prime factorization of 3825 is 5 power 2 into 3 power 2 into 17. So which is option C. So next question number 2. The least prime factor of 7429 is. So here you have to find least prime factor of 7429. So we divide it by 17. The first prime number which divides 7429 is 17. So when we divide by 17, so we get 437. Again 437 is divisible by 19. So then we get 23. So here prime factors of 7429 are 17, 19 and 23. That is 7429 can be written as 17 into 19 into 23. And here least prime factor is 17. So which is option C. So here correct option is option C. That is least prime factor of 7429 is 17. So next question number 3. The factor tree of 510 is as follows. So here factor tree of 510 is given. You have to find the value of A and B. So directly we can find the value of A here. That is 2 into which number is 510. So we have 2 into 255 equal to 510. So therefore A value is 255. So A value is 255. That is 2 into 255 equal to 510. So therefore A value is 255. So then how to find B value? So that is when we multiply 5 and 17. 5 into 17 is 85. So therefore B value is 85. So here B value is 85. So therefore here option D is correct option. So that is A value is 255 and B value is 85. So which is option D. So next question number 4. So 7 into 11 into 13 plus 13 is, you have to find whether this number is prime number, composite number, odd number or irrational number. Now here 7 into 11 into 13 plus 13. So here 13 is common. So we can take common outside and we can write it as 13 into 7 into 11 plus 1. So here 7 into 11 is 77. 77 plus 1 is 78. So therefore given number can be written as 13 into 78. So that is given number can be written as product of two numbers. So therefore it is composite number. So here correct option is option B. That is given number is a composite number. So next question number 5. If two positive integers A and B are written as A equal to x cube y square and B equal to x y cube, where x and y are prime numbers, then HCF of A and B is. So here you have to find HCF of A and B. So here x and y are prime numbers. Now to find HCF, you have to find least power of x and y. So here we have x cube and x. So least power is x. And in y square and y cube, least power is y square. Therefore HCF of A and B is x into y square. So which is option B. So here HCF is x into y square. That is you have to select least power of x and y. So here it is x into y square. So next question number 6. If two positive integers p and q can be expressed as p equal to 3ab square and q equal to a cube b, where a and b are prime numbers, then you have to find LCM of p and q. So here when we find LCM, you have to find highest power of variable. But here one number is given, it is 3. And here number is 1. So first we have to find LCM of 3 and 1. So LCM of 3 and 1 is 3. And in A and A cube, so LCM is A cube. And B square and B, LCM is B square. That is we have to write highest power of the variable. That is here we have A and A cube. So highest power is A cube. And here we have B square and B. Highest power is B square. So therefore LCM is 3 A cube B square. So which is option C. So here correct option is option C. So next question number 7. LCM of 12, 15 and 21 is. So here we can use prime factorization method or we can use division method. So divide all these numbers by a common number. That is we can divide 12, 15 and 21 by 3. So when we divide this, we get 3 4s are 12, 3 5s are 15 and 3 7s are 21. And then there is no common factor in this 4, 5 and 7. So therefore LCM is 3 into 4 into 5 into 7 which is equal to 420. So which is option D. Or else we can use prime factorization method. That is 12 can be written as 2 into 2 into 3. That is 2 square into 3. So which is 12. That is 4 into 3 12. So same type 15 can be written as 3 into 5 and 21 can be written as 3 into 7. And you have to find LCM. Here in 12 we have 2 square and there is no other 2 square. So therefore LCM is 2 square into here we have 3. Here also we have 3. Here also we have 3. into 3. Then we have to write 5 here. So it is 5, and here we have 7. So it is into 7. So therefore LCM is 2 square into 3 into 5 into 7, which is equal to 420. So which is option D. So here division method is easy. That is divide given number by a common number and find LCM. So that is here LCM is 420, which is option D. So next question, question number 8. HCF of 26 and 91 is. So here we have to use prime factorization method. So the 26 can be written as 2 into 13 and 91 can be written as 7 into 13. And here common is 13. So therefore HCF of 26 and 91 is 13. So which is option B. So here we have to use prime factorization method to find HCF. So which is 13 here. So next question, question number 9. HCF of smallest prime number and the smallest composite number is. So here we have smallest prime number, which is 2, and the smallest composite number, which is 4. We have to find HCF of 2 and 4, which is 2. So it is option B. Here smallest prime number is 2 and smallest composite number is 4, and we have to find HCF of 2 and 4, which is 2, which is option B. So next question, question number 10. The ratio of LCM and HCF of the least composite number and the least prime number is. We have to find the ratio of LCM and HCF of least composite number, which is 4, and least prime number, which is 2. We have to find first LCM and HCF, then we have to find its ratio. So LCM of 2 and 4 is 4, and HCF of 2 and 4 is 2. Therefore ratio of LCM and HCF is 4 is to 2, which is same as 2 is to 1. So which is option B. So here correct option is option B. That is ratio of LCM and HCF is 2 is to 1. So next question, question number 11. If the HCF of 65 and 117 is expressed in the form of 65m minus 117, so then the value of m is. That is HCF of 65 and 117 is written in the form of 65m minus 117, and you have to find the value of m. First we find HCF of 65 and 117. That is 65 can be written as 5 into 13 and 117 can be written as 3 into 39. Again 39 can be written as 13 into 3. So therefore 117 can be written as 3 square into 13, and here HCF is 13. So HCF of 65 and 117 is 13, and 13 can be written as 65m minus 117, and we have to find m value. So take 117 to other side. That is 13 plus 117 equal to 65m. That is 13 plus 117 equal to 130, and take 65 to this side. So we get 130 divided by 65, which is equal to 2. So therefore m value is 2. So which is option B. So here m value is 2. That is 130 divided by 65. So which is 2, which is option B. So next question, question number 12. The sum of two numbers is 1000 to 15 and their HCF is 81. Then the possible number of pairs of such numbers are. So here it is given sum of two numbers is 1000 to 15 and their HCF is 81. So we have to find all the possible numbers of pair of such numbers. So here it is given HCF is 81. So we take two numbers as x and y. So therefore x can be written as 81 into a and y can be written as 81 into b. And here important is a and b are relatively prime. So that is there is no common factor in a and b. So here HCF of a and b is 1. So here a and b are relatively prime. So then it is given sum of two number is 1000 to 15. So therefore we can write 81a plus 81b, that is x plus y equal to 1000 to 15. So therefore here 81a plus 81b equal to 1000 to 15. And here 81 is common. So we can take 81 common outside and we can divide 81 to this side. So we get 1000 to 15 divided by 81 equal to a plus b, which implies a plus b equal to 15. So we get a plus b equal to 15. So now we find all the pair of relatively prime numbers whose sum is 15. That is 1 and 14. So 1 and 14 are relatively prime, and 1 plus 14 is 15, and 2 and 13 are relatively prime, and 2 plus 13 is also 15, and 4 and 11 are relatively prime, and 4 plus 11 is 15, and 6 and 7 are relatively prime, and 6 plus 7 is also 15. So therefore we have only 4 pair of such numbers. So therefore correct option is option C. So here we have 4 pair of such numbers. So we have only 4 pairs. So next question, question number 13. The largest number which divides 70 and 125, leaving remainder 5 and 8 respectively is. So here we have to find largest number which divides 70 and 125, but we have to get remainder 5 and 8. That is, we have to find the HCF of 70 minus 5. That is, we have to get remainder 5. Therefore, the number is 70 minus 5. And when we divide 125, remainder is 8. Therefore, the number is 125 minus 8. That is, we have to find HCF of 65 and 117. So here 65 can be written as 5 into 13 and 117 can be written as 3 into 39, which is same as 3 into 3 into 13. So which is 3 square into 13, and here HCF is 13. Therefore HCF of 65 and 117 is 13. So therefore required answer is 13. So which is option A. So here correct option is option A. So next question, question number 14. that is HCF of 5 by 6 and 4 by 9 is. So here two fractions are given and we have to find HCF of that number. So here HCF of a fraction, when we find HCF of a fraction, first we have to find HCF of the numerator, then we have to find LCM of denominator. That is HCF of 5 by 6 and 4 by 9 is HCF of 5 and 4, that is numerator, and LCM of 6 and 9, that is denominator. So therefore here HCF of 5 and 4 is 1 and LCM of 6 and 9 is 18. So therefore required answer is option C, so which is 1 by 18. So here correct option is option C. So next question, question number 15. So it is LCM of 5 by 8 and 3 by 4 is. So here also two fractions are given. We have to find LCM. So LCM of two fraction is LCM of numerator divided by HCF of denominator. So here LCM of given number is LCM of the numerator, that is LCM of 5 and 3 is 15, and HCF of denominator, that is HCF of 8 and 4 is 4. So therefore LCM of 5 by 8 and 3 by 4 is 15 by 4. So which is option C. So here correct option is option C. So next question, question number 16. The product of two number is 493 and their LCM is 493. So then their HCF is. So here we have one property, product of HCF and LCM equal to A into B, that is product of two numbers. So here HCF equal to A into B divided by LCM. So here A into B equal to 493, that is product of two number is 493 and LCM is also 493. So we get 493 by 493 which is 1. So therefore HCF of two number is 1, so which is option A. So here correct option is option A. So next question, question number 17. The HCF of two number is 18 and product is 12,960. So then their LCM is. So here also we use same property, that is HCF into LCM is A into B, and here we have to find LCM. So therefore LCM equal to A into B divided by HCF. It is 12,960 divided by 18, so which is 720 and which is option C. So here correct option is option C. So that is HCF into LCM is A into B. So therefore LCM equal to A into B divided by HCF. So which is 720. So next question, question number 18. If x and y are prime, then the product of HCF and LCM of x square y to the power 5 and x cube y square is. So here we have to find product of HCF and LCM. So here also we use same property, HCF into LCM equal to A into B. So that is directly we multiply this. Here no need to find HCF and LCM. So directly we write product of HCF into LCM is product of two numbers, that is x square into y to the power 5 into x cube into y square. So here x square into x power 3 is x power 5. Y to the power 5 into y square is y to the power 7. Therefore product of HCF into LCM is x to the power 5 into y to the power 7. So which is option D. So here correct option is option D. So next question, question number 19. If x into y equal to 180, that is product of two number is 180 and HCF of x and y is 3, then LCM of x and y is. So again we have to use same property, that is product of two numbers x into y equal to HCF into LCM. So here x into y is given, x into y is 180 and HCF is 3. So therefore LCM is 180 divided by 3 which is 60. That is LCM equal to 180 divided by 3 which is 60. So which is option C. So here correct option is option C. So next question, question number 20. The LCM of two prime numbers P and Q, so where P is greater than Q is 221, find the value of 3P minus Q. So here it is given LCM of two prime numbers P and Q is 221. Therefore here P and Q are relatively prime, that is HCF of P and Q is 1. So since both P and Q are prime numbers, there is no common factor for P and Q. Therefore HCF of P and Q is 1. Then we have A into B equal to HCF into LCM. So therefore P into Q, that is given two numbers are P into Q. So it is HCF into LCM is 221 into 1. So which is 221. So that is P into Q equal to 221. So since 221, so 221 can be written as 17 into 13 only. So here P equal to 17 and Q equal to 13. So we have to find 3P minus Q. So therefore 3P minus Q is 3 into 17 which is 51 minus 13. So 51 minus 13 is 38. So which is option C. So here 3P minus Q is 38 which is option C. So next question, question number 21. The LCM and HCF of test marks of Ravi and Raj are 13 and 182 respectively. So here LCM is 13 and HCF is 182. If Raj scored 91, then the score of Ravi is. So here also we use property A into B equal to HCF into LCM. So here B value is HCF into LCM divided by A. So which is 13 into 182 divided by 91. That is HCF is 13, LCM is 182 and marks of Raj is 91. We have to find Ravi marks which is 13 into 182 divided by 91. So which is 182 divided by 7. So here it is 13 ones and 13 sevens. So which is 182 divided by 7. So which is 26. So which is option D. So here correct option is option D. So next question, question number 22. 135 pens and 225 pencils are distributed to students so that each student gets equal number of pen and pencils. So then the maximum strength of the class is. So here 135 pens and 225 pencils are distributed to all the students, and all the students get same number of pens and pencil. We have to find total strength of the class. So here total strength of the class is HCF of 135 and 225. So now we find HCF of 135 and 225. So here 135 can be written as 5 into 27, so which is 5 into 3 cube. And 225 can be written as 5 into 45. Again 45 can be written as 9 into 5. Therefore 225 can be written as 5 square into 3 square. And then we can find HCF using prime factor method. So here we have common 5, and in 3 cube and 3 square is common. So we get 9 into 5, which is 45. So therefore required answer is 45, which is option B. So here maximum strength of the class is 45. So next question number 23. 3 bells ring at an interval 4, 7 and 14 minutes. All 3 bells ring at 6 a.m. When the 3 bells will ring together next. So you have to find when they will ring together. Here it is given 3 bells ring at an interval 4, 7 and 14. The time they will ring again together is LCM of 4, 7 and 14. So that is LCM of 4, 7 and 14. So here we use division method. So it is we divided by 2. So we get 2, 7 and 7. Again 7 is common. We divided by 7. So we get 2, 1, 1. That is LCM is 2 into 7 into 2. So which is 14 into 2, which is 28. So therefore here LCM is 28. That is 3 bells will ring together after 28 minutes. Therefore time is 6:28 a.m. That is the time when the 3 bells will ring together. Next is 6:28 a.m. So which is option C. So here correct option is option C. So next question number 24. 3 bulbs are such that they will glow for every 24 seconds, 36 seconds and 54 seconds respectively. All of them glow at once at 7 p.m. So then the time again they will glow together is. So here also we have to find LCM of 24, 36 and 54. So here 24 can be written as 8 into 3. It is 2 cube into 3. And 36 can be written as 9 into 4. So which is 2 square into 3 square. And 54 equal to 27 into 2, so which is 2 into 3 cube. So here we have 2 cube and 2 square and 2. So LCM is 2 cube, and here we have 3 square and 3 cube. And LCM is 3 cube. Therefore, LCM of 2 number is 2 cube into 3 cube. So which is 8 into 27. So which is 216 seconds. That is all the bulbs will glow together after 216 seconds. That is 3 minutes and 36 seconds. That is you have to divide 216 divided by 60. We get 3 minutes. That is 60 into 3 is 180. And remaining is 36 seconds. So that is 3 minutes and 36 seconds. Therefore, all the bulbs will glow together after 3 minutes and 36 seconds. So therefore, time is 7, 3, 36. That is 7 or 3 minutes and 36 seconds, so which is option C. So here correct option is option C. So next question number 25. The least number that is divisible by all the numbers from 1 to 10 is. So here instead of finding the number, we check which number is divisible by 110. So here 10 is not divisible by 3. So therefore option A is wrong. So here 100 is not divisible by 3. So therefore option B is also wrong. 504 is not divisible by 5. So it is not divisible by 5. So therefore option C is also wrong. So here remaining is 2520. So this number is only divisible by all the numbers. So therefore correct option is option D. So here we have to find a number which is divisible by all the numbers. That is the number should be divisible by 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So here 10 is not divisible by 3. 100 is not divisible by 3. 504 is not divisible by 5. And 2520 is divisible by all the numbers. So therefore correct option is option D. So next question number 26. If n is a natural number, then 6 to the power n end with the digit. So here we have 6 to the power 1. 6 to the power 1 is 6. And 6 to the power 2 equal to 36. And 6 to the power 3. So like this we have to continue and we have to find the last digit. This is very simple question. So if you take any power, the last number is always 6. Therefore 6 to the power n always end with only 6. So therefore correct option is option D. So we take 6 to the power any number. So last digit is always 6 only. So which is option D. So next question number 27. Prime factor of the denominator of a rational number with the decimal expansion of 44.123 is. Here decimal expansion of one rational number is 44.123. We have to find prime factorization of the denominator. Since the decimal expansion has terminating decimal, factors of the denominator is of the form 2 to the power n into 5 to the power m only. That is, in denominator if we have 2 to the power n and 5 to the power m, then only it is terminating. So therefore here correct option is option C. That is, prime factor of the denominator should be of the form 2 to the power n and 5 to the power m only. Therefore correct option is option C. So next question number 28. The decimal expansion of pi is whether it is terminating, non-terminating and repeating, or 3.14, or it is non-terminating and non-repeating. So here important, pi is not 3.14, pi is approximately equal to 3.14. And here one more important, pi is also not equal to 22 by 7. So pi is approximately equal to 22 by 7. So therefore here pi is not a rational number. So pi is not equal to 22 by 7. Now here pi is irrational number. So decimal expansion of an irrational number is non-terminating and non-repeating, so which is option D. So here pi has decimal expansion which is non-terminating and non-repeating since it is irrational number. So pi is irrational number, so therefore it has non-terminating and non-repeating decimal expansion. The next question number 29. The decimal expansion of real number n is 4.31, 32, 33, 34, etc. So then n is, you have to find n is rational number, irrational, prime or even. So here decimal expansion is non-terminating and non-repeating. So here numbers are not repeated. So therefore it is an irrational number. Here decimal expansion is non-terminating and non-repeating. Hence it is irrational, which is option B. So here correct option is option B. So next question number 30. The decimal representation of 23 divided by 2 cube into 5 square will be. So whether it is terminating, non-terminating, non-terminating and repeating, and non-terminating and non-repeating. So here in denominator we have only 2 power 3 and 5 power 2. So since denominator is of the form 2 to the power n into 5 to the power m, so it has terminating decimal expansion. So which is option A. So next question number 31. Which of the following rational numbers has a terminating decimal expansion? So here numbers are 2 by 15, 11 by 160, 17 by 60 and 6 by 35. If the number has terminating decimal expansion, the denominator should be of the form 2 to the power n into 5 to the power m. So here 15 is 5 into 3, so therefore it is not terminating. And here 160 can be written as 16 into 10 and 16 can be written as 2 to the power 4 into 2 into 5, that is 10 can be written as 2 into 5. So therefore 160 can be written as 2 to the power 5 into 5. Therefore here denominator is of the form 2 to the power n into 5 to the power n. Therefore 11 by 160 is terminating decimal expansion. And here 60 cannot be written in the form of 2 to the power n into 5 to the power n, and 35 cannot be written in the form of 2 to the power n into 5 to the power m. So therefore only correct option is option B, that is 11 by 160 has terminating decimal expansion. So next question number 32. The decimal expansion of the rational number 13 by 3125 is. So here we find whether denominator is of the form 2 to the power n into 5 to the power m or not. So here when we divide 3125 by 5, so we get 625. That is 3125 can be written as 625 into 5. Again 625 can be written as 5 to the power 4. Therefore 3125 can be written as 5 to the power 5. So therefore denominator is of the form 2 to the power n into 5 to the power n. Therefore given number, that is 13 by 3125, has terminating decimal expansion. So which is option A. That is decimal expansion is terminating. So which is option A. So next question number 33. The decimal expansion of 29 by 343 is. So here also we check 343 can be written as 2 to the power n into 5 to the power n. So here 243 can be written as 7 cube, that is 7 into 7 into 7. So therefore it is not of the form 2 to the power n into 5 to the power m. Therefore it has non-terminating decimal expansion. So but in option B and option D, here it is given non-terminating and here it is given repeating and here it is given non-repeating. We have to find which option is correct. Here denominator is not of the form 2 to the power n into 5 to the power n. Therefore it is non-terminating and given number is a rational number. So therefore rational number should have terminating decimal expansion or non-terminating and repeating decimal expansion. Therefore option B is only possible. So here decimal expansion is non-terminating but it is repeating since given number is a rational number. So which is option B, that is 29 by 343 has non-terminating and repeating decimal expansion. So next question number 34. The decimal expansion of the rational number 21 by 2 square into 5 cube into 7 is. In denominator we have 2 to the power 5 to the power and 7. So directly don't conclude that it has non-terminating decimal expansion. So here we can simplify this. So we can write 7 ones and 7 threes. So we can write given number as 3 divided by 2 square into 5 cube. So therefore here denominator is of the form 2 to the power n into 5 to the power m. So therefore it has terminating decimal expansion. So which is option A. So first simplify the given number. So we can write given number as 3 divided by 2 2 square into 5 cube. So therefore it has terminating decimal expansion, so which is option A. So next question, question number 35. The decimal expansion of the rational number 35 by 50 is. So we have to find decimal expansion of the rational number 35 by 50. To find decimal expansion, we can convert denominator into 10 or into 10 to the powers. That is, in denominator we have to write 10, 100, 1000, etc. So here in denominator we have 50. When we multiply 50 by 2, we get 100. So therefore we multiply both numerator and denominator by 2. That is 35 into 2 is 70 and 50 into 2 is 100. So we get 70 by 100, which is 0.7. So which is option C. So here in denominator we have to get 10, 100, 1000 like that. So here directly we multiply by 2. So we get 70 by 100, which is 0.7. So which is option C. So next question, question number 36. The decimal expansion of the rational number 17 by 8 is. So here direct multiplication of some number is not possible. So first we write 17 by 8 as 17 by 2 cube. So then we multiply by 5 cube. That is 2 cube into 5 cube is 10 to the power 3. So that is 2 into 5 is 10 and we get 10 to the power 3. So therefore given number can be written as 17 into 125 divided by 10 cube. So that is 5 cube is 125. So 17 into 125 is 2125 divided by 1000. So which is equal to 2.125. So therefore decimal expansion of 17 by 8 is 2.125. So which is option A. So here correct option is option A. So here denominator is 8. 8 can be written as 2 cube and here we have to get 10 to the powers. So therefore we multiply by 5 cube and we get 10 to the power 3. So therefore decimal expansion of 17 by 8 is 2.125. So which is option A. So next question, question number 37. The decimal expansion of 14,587 divided by 2 into 5 to the power 4 will terminate after. We have to find decimal expansion will terminate after how many decimal places. Now here it is given number is 14,587 divided by 2 into 5 to the power 4. So here we have 5 to the power 4 and here we have 2 to the power 1. We multiply both numerator and denominator by 2 to the power 3. That is in denominator we have to get 10 to the power 4. We multiply by 2 to the power 3. That is 14,587 into 8 is 1,16,696 divided by 10 to the power 4 and 10 to the power 4 is 10,000. So when we divide this we get 11.6696. Therefore given number will terminate after 4 decimal places, which is option D. So here decimal expansion of the given number is 11.6696. So which is terminating after 4 decimal places. So correct option is option D. So next question, question number 38. The decimal expansion of 14,587 divided by 1,250 will terminate after. So here also we have to find decimal expansion will terminate after how many decimal places. So here we have in denominator 1,250. So we multiply by 4 to get 5,000. That is when we multiply 1,250 by 4 we get 5,000. That is we multiply both numerator and denominator by 4. So that is 14,587 into 4 is 58,348 and in denominator we get 5,000. And again we multiply numerator and denominator by 2 to get 10,000. So we get 58,348 into 2 is 1,16,696 divided by 10,000, which is equal to 11.6696. Therefore decimal expansion of the given number will terminate after 4 decimal places, which is option D. So here also correct option is option D. So next question, question number 39. The smallest number by which 1 by 13 should be multiplied so that the decimal expansion terminate after 2 decimal places is. So here given number is 1 by 13. We have to multiply 1 by 13 by sum of these numbers and the resulting number should be terminate after 2 decimal places. So here we multiply 1 by 13 by 100. So that is 1 by 13 into 13 by 100. It is 1 by 100. So which is 0.01. So therefore when we multiply 1 by 13 by 100, the resulting number will terminating after 2 decimal places. So therefore correct option is option A only. If we multiply 1 by 13 by any other option, so it will not terminating after 2 decimal places. So here correct option is option A. So which is 13 by 100. So next question, question number 40. If A square is 23 by 25, then A is. So here A square is 23 by 25 and we have to find A value. So here A value is root of 23 by 5. That is A square is 23 by 25. Then A equal to root of 23 by root 25. Root 25 is 5. So therefore we get A equal to root 23 by 5. And here root 23 is irrational number. So therefore irrational number 5 is also irrational number. So therefore A equal to root 23 by 5, which is irrational. So therefore correct option is option B. That is here A is irrational number. So which is option B. So that's all in this video. Watch other chapter explanation in my YouTube channel Aakruthi Mathematics Classes. Thank you for watching. Please like, share and subscribe the channel for more video notification. Thank you once again.